morning. So according to the program, this talk is in English. So excuse me. Okay. It's morning. I'm really excited to see you all here. Let's cheer up a little bit. Just put a smile on your face and let's take a photo. One moment. Okay. Woohoo! Cool. Thank you. Okay, let's do it. So today we're talking about the role of a solution architect in a software project. Small disclaimer here. So everything you see here or whatever, everything is a product of a production and research experience and reading some books actually. So please accept it as is. There are no guarantees this is all true. Okay, about me, my name is Vladimir Ivanov. I'm lead software engineer in EPM systems. We call it primary skill, so my primary occupation is Android development. I'm doing mobile applications for more than 7 years, but it's not the limit for my technical interests. I'm doing some cross-platform mobile development with React Native, for example, and I'm doing solution architecture from time to time for different projects. Recently, I passed the Google Cloud Architect certification, and that was tough but cool. Okay, so I got that kind of badge for that. Okay, so let's get to know each other. Please raise your hand. Who is a software developer, like writing code every day? Okay, good. A lot of you. What about QA engineers? Virtually no QA engineers here. Okay, one. What about managers, like program managers, 5, 6, 7 delivery managers? Resource managers? What kind of managers you do know? Okay. Any architects, solution architects, enterprise architects? Okay. 2. You colleagues can correct me if I'm bullshitting you. Okay. Okay. So there are different phases of the projects, but usually developers know only one of them. It's a construction phase. But actually, for the software services company, there are much more, and we're going to go through all of them today. So there are RFI, request for information, request for proposal, then engagement, discovery, construction, you all know, and transition. Okay, let's go just one by one. First one is request for information. This is a very simple stage. Basically, a customer reaches you with questions, and they want to know what software development capabilities you have. Are you proficient with mobile development? Do you know how to build web applications with Node.js? Can you customize some Drupal-based sites? And so on. And this is the moment when solution architect begins his work, right? His responsibility is to answer those questions. And of course, you can't know everything. You can't know the answer for each of those questions. And if you don't, you're going to reach some architects of related fields. For example, your primary occupation is mobile development, the same as myself, and they ask you about Drupal or other web technologies. You're going to find the architects in that field and ask them those questions and provide his or her answers to the customer. And if you don't have such experts, for example, the customer wants to know if you have any experience with blockchain, you can't just answer that, I don't know anything about it. It's not serious, right? You're going to do some research and answer that we have some information about that field, we know that and this, so we can do something for you. Okay, this is a simple stage. The next one, if the previous goes really well and the answers are good, you're going to have a request for proposal. This is the beginning of real work because they want to know how much money and time you require to build some kind of software project, right? So you get a letter or a document or whatever with some kind of requirements and vision and so on. And our solution architect is going to understand what is the business value for that software project. Because no software is written just to be written, right? That software should earn some money. They should bring some business value. And our architect should understand what is the value of a concrete request. Then the architect is going to create a solution architecture, right? To draw some fancy diagrams, to understand which components are required for that solution. And if the architect knows which components exist in that architecture, then he can understand which teams are required to implement that solution. Because you don't generally do only one part. You're creating a system, right? So you will need a backend, a front end, a load balancer, a mobile application, a website, a data storage, and so on. And for each of those components, you will require a separate team or a separate person, or maybe a person who works on several components simultaneously. If you know the teams, you then create a resource plan. This is a document that describes which persons of which occupation, like senior developer, team lead, solution architect, delivery manager, QA lead, QA engineer, QA automation engineer, and so on. And this is the base for the cost calculation, right? Because if you're a software services company, like EPAM, what you sell is the time of your engineers. So we want to position ourselves like a software services, but basically we sell the time of our people, right? So when you have the resource plan, you know the time and money you need to create that solution, to implement that solution, and this is the information that the customer wants to know, right? So this is the answer to the request for proposal. Okay, good. What about the next phase? The next phase is engagement, and our solution architect does really little in that part. Maybe he consults the account manager or delivery manager and just reaches the customer to ensure that we have all the technical possibility to do the project. But the most interesting part is the next one, is the discovery. Okay, let's talk about discovery. The main goal of that phase is the requirements gathering, because without requirements, you can't really understand what you need to do and how much money you really need. Because in the previous phase, you have just a short vision of what you're going to build. But only discovery can answer all your questions. So our requirements could be, first of all, functional, right? We all know what functional requirements is. Non-functional, and constraints. Okay, let's talk about each of them. First of all, functional requirements. This is really easy. I believe everyone can give me some examples of functional requirements. For example, the system should allow an administrator to log in, right, to get into the system. Okay, pretty clear. Or the system should show the list of users to the logged in administrator. Pretty clear as well. And we basically don't have any issues with those functional requirements because they're clear, and if they are not, we can pose just a couple of questions and get all the answers we need. The more interesting part is non-functional requirements, because those requirements tell us how the functional requirements should be implemented. Because, for example, the system should allow an administrator to log in. Will you be satisfied if it will take 20 minutes? I believe nobody will. So we need to gather non-functional requirements that tell us how our system should behave and how it should implement our functional requirements. For example, if you have some security requirement, like the application should use TLS 1.2 for all connections involving user data. Okay, so here you understand that HTTP is not the choice of your architect, okay? Or maybe the application should open the page under half a second. 20 minutes is not satisfying, right? So half a second is okay. Or maybe the application should be available 23 hours a day. Or maybe 23 hours and 59 minutes. Okay. Aside of functional and non-functional requirements, there are constraints. Those requirements are not dependent on the customer or on you or on whatever else. They are just given facts. For example, customer already has a license for Azure Cloud. And they just tell you that we already have a license. We don't accept GCP. We need to use Azure. You can't do anything with that. Or maybe the application should implement some federal law regarding the data. If you build a medical solution, right, or you build some financial thing, you will have a lot of constraints here because it's just life. Okay, why those requirements are important? Why we talk about them so much? Because some of them will change the architecture a lot, and that means that will change the cost a lot. For example, if you have an availability requirement, and availability is usually given in some number of nines, for example, 99.9 or 99.95, or 99.99999. There's a service I know, Google Cloud DNS, that provides 100% availability, but this is the only one, I believe. And every additional 9 of your availability requirement is going to double the complexity of your system. And that means doubling the costs, right? So this is a disaster, and you need to know those numbers precisely before you do the actual project. And of course, the earlier you understand that you have some requirements, and the earlier you can avoid some errors, the cheaper it will be to fix the problems that you will come up with during the project. Okay, the main source of our requirements are stakeholders. Who they are? They are the people who have an interest in your project. So there are a lot of people, actually, for each of the projects you can meet in your professional life. First of all, customer business representative, right? Those are main guys that drive all the deal. Maybe delivery organization business representative, so your account managers, your, I don't know, CEO, and so on. Technical folks from both sides, right? So customer can have their own developers, IT department, solution architects, QA engineers, and so on. Of course, you will have them too. So your developers, your QA engineers, your managers, yourself, all technical folks. End users, of course, are interested in your project because your project is going to bring some business value to them as well. And competitors. Of course, your competitors of your customer are not going to be interested in a successful completion of the project because they're going to ruin their business in a good case. So those are interested people, and you need to listen to them very well. So in order to gather requirements, you need to talk to those stakeholders. That's obvious on this step. And the stakeholders identification is one of the main responsibilities of a solution architect. So that's basically what you do like half of the time. We're talking a lot about architecture, but we didn't give any definition. There's a very smart book, Software Architecture in Practice, from the Software Engineering Institute. And the definition is that the architecture is the set of structures needed to reason about the system, which comprises software elements, relations among them, and properties of both. Does anybody understand anything? I don't. Well, actually, I do. But from the first sight, you don't understand anything. And there are like 3 pages in this book that explains that this definition is really correct comparing to other definitions and so on. But now we can understand that architecture is a key to the system properties, which the end user is concerned about. So when we were talking about the performance, this is really concerning for end users, and you need to design for that requirement. Or maybe your product owner or some business representative think that those requirements are important. They can be wrong, but they think so. So in general, there are no good or bad architectures. There are architectures that fit the target system properties, and the architectures that just simply don't. Okay, so the target system properties that we're talking about, which affects the architecture significantly, they unsurprisingly called architecturally significant requirements, or ASRs. And the architects are just, when they chit-chat during their coffee, did you gather all the ASRs? Okay, of course I did. Okay, let's go further. How to identify ASRs? How do you do your job? So you can review some requirements documents, and of course there will be some lists. You can interview stakeholders, and there are separate processes on how to do that well. For example, with quality attribute workshops. Again, those are complicated processes actually. By understanding the business goals, so for example, you're building a mobile application and you want to engage some people, you of course understand that those applications should be performant, because if they are not, the user is going to uninstall them just in a second. And there is some tool, it is called utility tree. It is really helpful to gather those architecturally significant requirements. How to use it? Let's check. Well, what you do, you're going to interview your stakeholders with quality attribute workshops, or just one by one, or whatever. And you're going to gather just a list of requirements. Different ones. For example, on the normal load, the web page is displayed within half a second. By the way, those requirements in that formula are called quality attributes. because they provide precise numbers on your non-functional requirements. Another example is, well, in case of system failure, new instance or your application is up in under 30 seconds. Okay, what do you do with those lists? You categorize them by what they tell you about. For example, the first 3 ones are about the response time of your system, right? The last ones are about compliance or user experience. When you grouped those requirements by their mean, you can group them in some larger groups. So, for example, response time and latency of the group performance. And the last one is compliance, it's for usability, and so on. So you see that you have a tree-like structure, and you see all the requirements, and it really helps to understand how you're going to design your system to address all of those requirements. Okay, cool. So you gathered all the requirements, you came up with the solution architecture, you spent a lot of time with it, and now you need to document it. How? With some notations, of course. So there are 3 kinds of notations. This is the definition from a Software Engineering Institute, again. So first ones are non-formal notations with general purpose diagramming. So you can just take Word or Paint or whatever other tool and draw some rectangles, and this will be non-formal notation. And they require a legend, right? So to bring value. The next one are semi-formal notations, and they have standardized notation. So they provide some meaning for those rectangles, and you can think that other architects, they know that notation, and they can understand what you're drawing. And the last one are the formal notations, and they differ from previous one with precise semantics, right? So you can know that some rectangle brings some value, but only in formal notations, there are precise meaning. So you don't need to pose any other questions to understand what the diagram is about. Okay, let's take a look on some examples. So you cannot read like the titles here, just the picture. You clearly see that this is a non-formal notation because they're just drawings, some homes, some squares, some servers. And of course, the architect who does that, he needs to provide a legend, right? To provide the meaning to the diagram. Another example is this one. I believe you don't see anything here, but there are a lot of errors here, and rectangles, and braces, and labels, and so on. And this is semi-formal notation. So this is UML 2.0, I believe. But you don't need a legend to understand that. However, you can't use some verification, so some software to prove that this architecture means anything. Okay, let's go further. In formal notations, you can use some software to do that. Okay, so documenting the architecture is the third most important activity for a solution architect. And of course, you don't share only diagrams with other architects or with your customer or whatever. You provide documents, for example, solution architect document, and there are a lot of templates for those. We have some internal ones. The Solution Engineering Institute have a lot of them, and so on. Okay, the next phase is actually construction. And during construction, our solution architect can do a lot as well. So they don't just share the solution architect document and wave you and bye-bye, I'm not going to develop that. Okay, he's going to do that. He's going to bootstrap the development, so maybe create some project templates and so on, write some code, define and set up quality gates, and this is really important because we were talking about some architecturally significant requirements. And if your system doesn't fit them, doesn't satisfy them, then when you're going to show the system to your customer, they will not be satisfied as well, and they're not going to pay you. So architect is here to ensure that those requirements will be met. And for those, he set up some quality gates. So for example, he sets up some automated tests that ensure that the system behaves really performant like it was in the requirements. And maybe architect creates some proof of concepts. If you need to integrate with some third-party systems or use some hardware, this is the responsibility of a solution architect. And of course, he's going to share some knowledge with developers, with QA engineers, with delivery managers, and other managers. Okay, the last phase solution architects plays role in is transition. What is transition? There are two types of transition of a software project. First one is to production. And this is the case of success. Like, you did everything you wanted, and you're going to deploy your system, and architect helps you to bring it live, like, right, deploy to the production cloud or to production system, and so on. Another type of transition is a transition to other team. There are several cases here, because, for example, you can, your system may be a part of a larger system, and you completed your work, but it's not going to go to production. It's going to be a part of a bigger one. Or maybe you're not doing great, and the project is transferred from your software services company to other one. Or maybe you just change the team, right? So you change the location. For example, you're doing it in Belarus, and you want to move it to St. Petersburg, and so on. So this is a transition, this is a knowledge sharing, and so on. Okay, so summing it all up, the person who identifies stakeholders, gathers architecturally significant requirements, building the architecture, documenting it, sharing it, bootstrapping some of the system components, that person is usually called a solution architect. In EPAM, we have a really sophisticated definition of who a solution architect is. And this is a huge list. I'm going to share some examples. For example, we require practical experience with more than 10 projects in relevant engineering domain. For example, 10 mobile applications or 10 web applications or whatever. Good knowledge of architectural theory, because you need to communicate with stakeholders, to communicate with other solution architects, with enterprise architects, and so on. You need to have to be on the same page, right? And, for example, an ability to identify stakeholders and communicate with them. This is crucial, right? We figured that out. Okay, so a couple of useful links. If you want to become a solution architect or want to become a better solution architect, there's a great article of the colleague of mine. He's called Nikolai Ashanin. And he wrote an article about the books in software architecture. This is not a plain list. There is a rating and comments and so on, so you can choose the best one for yourself. There are a couple of courses. For example, Amazon Cloud Architect Associate. This is a great course. It costs like $15, so it's basically free for that kind of course, so just enroll. The next one is Google Cloud Architect Professional, the one I took in order to pass the certification. It's a great course that not only giving you the knowledge of how you use GCP, but what architectural principles you apply to build a performant, scalable, large systems. And yeah, I engage you to enroll. And that's it. So there are a couple of contact information. You can reach me by working email. Follow me on Twitter, please. It's really important. Follow me on Medium. I write a lot about mobile application development and data development and cryptography and so on. So I expect you to reach me and to talk about a little more. Thank you.
Thank you. Thank you very much. I'm not sure that. Is it okay with this microphone? Yes. So we have time for several questions. Probably both English and Russian are okay. Yes?
Yeah,
Is
sure.
Hello? Oh, okay. Oh,
Whoa.
hello.
Interaction cube. So
Talk to the box.
is there some special name for this device already? Oh, okay.
Xbox, yeah.
Xbox.
I want to ask about agile technology when a requirement may change during development process. When, for example, customer initially wants to chat, and to end of a product, he wants chat with video calls. When handle these changes and how to process it?
Well, I believe I can answer that question. So almost all of our processes are agile. So we gather requirements in an agile style. We develop the product with iterations, with Scrum, and so on. So we're trying to show the result as fast as possible in order to have the feedback as soon as possible. And if the customer understands that he wants to change anything, we just look on that change, and if it is a really small one, just add some button here. We're just doing it. And of course, it depends on the type of engagement or on type of the contract, because if you have a time and material, if you have fixed price and so on, there are nuances, but this is a responsibility of account manager really. But if we see that the architecture will change with that requirement, this is definitely a change order, and we're trying to communicate. So this is a huge, huge change. We need to change architecture, add another team to satisfy this requirement. So this is a separate money, a separate contract, and so on. And it happens all the time. This is life. Okay?
So more questions. So
yeah, cool.
Vladimir, you mentioned that you are preparing documents. What is the main document you prepare, or a colleague of yours, and what does that document includes?
Okay, so during the engagement, we prepare like 10 documents, I believe. So it's a resource plan, a agile project management plan, risk management plan, statement of work, solution architect document, and the later is the document that actually solution architects writes. So solution architecture document. It includes like everything, the architecturally significant requirements, the diagrams. It may include baseline architecture if we're in brownfield and we need to transit the system from previous state to a new state. The target architecture with several views, the description of all of the components, but it depends on the customer, of course, because for some customers, we prepare only high-level architecture. So those are the blocks, this one, this component, and that's it. And for some, we provide really detailed architecture. So for example, the architecture of particular components of mobile applications. So this module in this mobile application consists of those components and so on. Did I answer the question? We have a discussion zone, I believe, there. We can talk a little bit more.
Yes, there is space for more detailed discussion, so please.
Okay.
You mentioned you use some diagrams for requirement specification, for functional requirements. Did you use some kind of BDD specification or this?
Well, I never did.
Why so? Because this is one of the way to
Yeah,
be linked to the stakeholders, no?
Yeah, definitely.
it's
I
very
just don't have such experience.
So more, here it is.
No, thanks.
Not right way, so you have to throw it. So
So you described like ideal process when you have a solution architect guiding the project through all the steps and controlling the process on each step, which is quite good, but that's not how it often happens in real life. Often you have already developed product that works, and you need to continue develop it and to extend it and to broaden it.
Okay.
So I believe the solution architect role in this case is a little bit different. So could you please comment on this situation?
Well, of course, there are a lot of situations. Well, when you have a brownfield, right, and you need to transit something.
I'm sorry, you have what?
Sorry?
You have what?
Brownfield. So there are two approaches, brownfield and greenfield. Greenfield, when you don't have anything, right, and you're building a solution from scratch. And brownfield, you already have a system, and you need to do something with it. And of course, there will be difference because you will begin with an architectural review. So when you gather some requirements, right, because you need to do something with the system, you will not just step into architecture. You will begin with the architectural review. And this is a separate process. I haven't a lot of experience with that, but whatever. You need to understand, you need to gather all the documents that describe in the system and maybe write some missing parts, and then make a conclusion if that system will target your properties, right, your quality attributes, and if it is not, then come up with a new architecture that will fit your business requirements better. Okay?
Yeah, I believe this is a very broad topic, so thanks.
Okay,
We can
okay.
talk later.
So we probably have time for one more question for this talk. So here.
Okay. It's a good case when we have an flow from the beginning, RFI, RFP, and so on from the development. But usually we met a situation when you have to assess assessment an existing project, maybe not on your company, maybe external company.
Yeah.
In that case, we need to prepare an assessment plan. Can you suggest any framework or methodology how we can prepare an assessment plan to assess external or internal project when the architect comes and have only 1 or 2 weeks to understand because the stakeholders and so on?
Unfortunately, I can't suggest some frameworks, but in my understanding, what you need to do is you need to go on site, right to the customer, and identify the most important people there, and try to communicate with them as much as you can in order to understand what happens now and what is the most dissatisfying thing about their solution at the moment. And then just proceed.
So I think
Okay.
that's been a good question for a separate presentation topic. I
Yeah,
think that prepares for
I believe so.
30 or 40 minutes, so I think at least. So I have to stop the discussion right now because we have to allow people to change the rooms, so you can find the speaker close to our room for some additional discussion. Thank you very much. So
Thank you.
small break here.